So the question is, did I have ChatGPT write my bio? As Morpheus would say. So we, as an industrial community or an industrial industry, are often, more times than not, slow to adopt new technology, especially software technology, for good reason, for obvious reasons. But every now and then, we have these new, emerging, groundbreaking technologies that have the potential to change the course of humanity, like the printing press, the automobile, the internet, and as I just learned in the keynote, Cheeto manufacturing. But the problem is, when we have this sort of technology, especially in OT, we find ourselves wondering, is this something that's going to be inevitable? Am I going to have to adopt this? How can I adopt this? Is there value? And is it safe? That's the big thing, right? Is it safe? And can I do it securely? And so I can't answer these questions for you. Whether it's going to be inevitable, I think it might be. Whether or not you can find value, whether or not you should. And I'm not here to discuss whether you should or shouldn't use generative AI. And to be clear, in this presentation, we're discussing generative AI as opposed to the more classical AI and machine learning. Okay, so we're going to talk about generative AI, specifically large language models. And mostly, like I said, I can't tell you whether or not you should use it. So what we're going to do is I'm going to talk to you about ways that we and our customers are using it now to get value and how we're doing it safely. And so these are some of the use cases that we are literally currently using it in production to get value. And so this would be aggregating huge amounts of data from asset management systems and SIMs and being able to quickly do a quick analysis, risk analysis, threat attack surface analysis, and these sorts of things. Now, is this going to replace humans? Not anytime soon, I don't think. But, as I'll mention later, remind you later, and I'm going to say it now because it's important, it should be used to augment your processes, to augment you, and to enhance your capabilities, and so we'll get into that. But we're also using it for network diagram analysis to find the details and potential risks and threats out of network diagrams. And I really probably should say vulnerability management rather than vulnerability assessment. But again, aggregating data and helping us with the process and the decisions of vulnerability management and assessment. And then finally, incident response preparedness, and specifically using it to automate tabletop exercise planning and facilitating. And so let's quickly take a look at a quick demo video of some of these in action. All right, so this first one is an asset management system where we're aggregating data, vulnerabilities, telemetry, and very quickly analyzing that data and providing a risk analysis, an attack surface analysis, and the MITRE ATT&CK TTP chains. And this next one is where we're pulling a drawing or an image of a network diagram and then using it to extrapolate all the data in the systems for use and to help plan and prepare for tabletop exercises. And are we doing this safely? What about that data? Where's it going? This is all local. This is a local, private, open source model. No data leaves the site. And for generating and facilitating tabletop exercises in seconds as opposed to weeks. Instantly being able to provide a few settings and let the AI do the rest. Let the AI configure it, set it up, do dynamic injects, and you'll hear here.
Introduction. Welcome to today's incident response tabletop exercise. I am here to facilitate this scenario.
She should tell me to shut up. But it's dynamically creating the voice as the narrative is being produced so it feels more human-like. And here, we're dynamically generating not only injects, but dynamically generating detailed logs using AI to generate all the detail and all the specifics of the tabletop exercise. So there are no more limits. You can just You can throw it curveballs, and it'll spit out all the detail you want. So how are we doing this? There's about 5 steps, 5 categories, the way that we're achieving this. And most importantly, the foundation of it all is the use of open source models. And the reason why is because open source models, and I know you can't see that, but let's say I'll talk about it in a minute. Open source models are going to keep your data on-site and private. So normally, and let's be clear also, we're not talking about ChatGPT. We're talking about writing code, writing apps on top of or in using APIs, whether that's your local API or even sometimes going out to the OpenAI API. But using the public APIs, that's when you're exposing your data. That's whenever your data is going out there into the cloud, into the ether, which contains sensitive information. So the use of private open source models that's what's going to keep it all in-house and keep it from leaving the site. There's a lot of different places to get open source models, but the most common one is here on Hugging Face. It's a site called Hugging Face, and there are models for just about everything, every purpose, multimodal models to where it can do voice, it can do audio, it can do image creation, image recognition, and of course, the typical large language model stuff that we all love through ChatGPT. So we also use a tool called LM Studio to very quickly and easily access these models. You can download them, you can search for them from LM Studio, search for them, download them, and then run them locally using LM Studio. So this is how we test our foundational models. Foundational models being the base model that's been trained by someone else because it's impossible for us to train our own models with our limited resources. And so you use LM Studio to download them and then run them. You can run it in a local server, allowing you to, this is basically the very first stage of letting you run local open source models, and the convenience factor of it is that if you are developing applications with OpenAI and their API, and you're familiar with the OpenAI API, most of these models are compatible with the OpenAI syntax and the API conventions from OpenAI, so it makes it easy to run. Now, the problem with LM Studio is that it's best for prototyping, not app development. If you want something that's 100% scriptable, then, oh, and sorry, forgot to mention this part, that you can use the GUI, the graphical user interface, to chat with those models just like you would in, say, ChatGPT. And then another tool that we use is Ollama. Ollama is completely scriptable. You don't need, or actually I don't even think it has a graphical interface, but this allows you to use that same system that we did with LM Studio, 100% scriptable, so you can build apps and scripts on top of it. Once you have your base, your foundational open source model, then you need to fine tune it. And the reason you need to fine tune it is because if you ever use ChatGPT, you know it can make mistakes, it hallucinates, it comes up with all this information that may be wrong, or it may not understand or have knowledge on a specific subject. So fine-tuning it allows you to specialize the model and make it more accurate. And so basically, for example, using one of the larger open source models, and unfortunately I don't have the time in 25 minutes to talk about all the details and nuances of the models, but if you're familiar with app development using any of the GPT models or open source models, you know that GPT-4 is currently the leading model. And it's the most accurate, it's the fastest, and yes, you can argue Google, Gemini, whatever, but GPT-4 is the leader. And so what we have found is that fine-tuning open source models, some of the quality ones like Llama 2, Mistral, when you fine-tune those, we're getting GPT-4-like accuracy and quality because it's domain specific. And that's the reason that happens is because your broad general models, they have so much information and they have to do inference in so many different vectors that it loses things, it misses things. But whenever you have a model that's fine-tuned specifically with the exact question and answer sets, then it hones in on that specific domain, and it's a lot more accurate. And so that's how you fine-tune the models, is you're basically taking this large amount of data, whether it's standards, Wikipedia, because that's accurate, and just anything that's going to give you your foundational knowledge, and you're generating question and answer sets. You can do this manually, it takes a long time, or you can script it. And so basically, it's really just a JSON object that just has a question and an answer, a question and an answer. And there's a script that we use, and I'll go back real quick, that's just, by the way, all of these scripts, I'll tell you at the end of the presentation, we have a location where all of these scripts that we use for training, for fine-tuning and everything, the methods, the process, it's all open source, and we have it in a project for you that you can get access to. So we automate the process, taking that data and generating hundreds, thousands, tens of thousands of question and answer sets. And then once we do that, we go back to Hugging Face, and they have a tool called AutoTrain. You upload all your training data, and it will fine-tune based off those question and answer sets through AutoTrain. And you can do this. You can see there at the bottom they have the hardware you can select. You can select the top quality GPUs, and it works relatively fast. Or if you've got a few weeks or a few months, you can do it for free using their CPU base. So this is how you would fine-tune those models. And again, you want to know specifically how to do this, we have free instructions in open source. Once you have your model fine-tuned, then you have what's called RAG, or Retrieval Augmented Generation. And what this is, so if you think of training, training takes a lot of data, a lot of time, a lot of money, a lot of hardware. Fine-tuning is that next step where it still takes hardware, still takes some time, but it's how you take that foundational model and you train it into a specific task. Now, Retrieval Augmented Generation is, that's what it is, it augments the model. So I can take data and what's called embedding the text with vectorized, or with vectors, basically builds a map of all the data so that the computers, the large language models, can access it easier and faster. And it's like giving it a supplementary library. So you have your fine-tuned model, and this is useful in cases where there's new emerging data, like new vulnerabilities or new standard that came out. So rather than taking that time and the resources to have to fine-tune all over again, then you can use retrieval, you can use RAG. Now, so the quick and easy way to do this is with a program called ChatGPT, which has a GUI as well as a scriptable interface or an API, and just basically script it to where, again, it's kind of like ChatGPT. You can upload your documents, and then this is all private because you can use a multitude of local open source models, and you can chat with it, chat with your data, chat with your documents. And so this could be standards, one of the ways that we use it. And so this is kind of a foundational between all the RAG, the Retrieval Augmented Generation, and those techniques are foundation to what we're doing with all this data analysis. So like, for example, with the risk analysis system that we built, that's how you keep up to date with the latest threats, the latest CISA alerts and everything like that, is by pumping that into the RAG system. However, let's say you have a standard and you have your security policy. It's kind of like what we're looking at here. You can of course, say upload, feed it, because it's not uploading anywhere, it's local. But you feed it those docs, and then you can do things like ask it if your cybersecurity policy is in compliance with this said standard. And you can start to compare documents and, well, just chat with your data. And so this is just a quick illustration to show, like, it's using the Mistral model, I guess. I could have photoshopped it and just lied to you, but trust me, I'm AI. And so this is just a quick example of the same thing that we showed in the private GPT interface. This is the actual code. So it's the same thing. It's the same prompt that you saw there. So look there, that's basically the same prompt and the same question, I think. Okay, maybe it's not. All right, I just lied. So either way, but it's a real simple script accessing local models using private GPT. And so this is pretty important here, is using multimodal models. And so there's a model called Lava, which is it's from Llama, from Meta, or Facebook, whatever they're called now. But it's the video recognition model. And so you can use, same thing, you can use private GPT or OLLAMA to use local models and then recognize the images. And so that's how we're doing the image recognition, that network diagram. So, and that's one of the tricks that I found is like, I tried to get it to read like the Visio XML, and it wouldn't do it. Even using ChatGPT 4's or ChatGPT Plus's advanced data analytics, used to be called code interpreter, it just would not properly read the XML. And so once the image recognition system, the vision models, got better, I learned that you just take an image of your network diagram, plop it in there, either through, typically scripting works best for that, and it reads it, and it's accurate. It's almost flawless every time, almost. So once you have your data preparation, so your foundational model, you're fine-tuned, you have your retrieval augmented generation, that's a mouthful. Next, this is the key foundation. This is the trick. This is the key to all complex functionality and use cases for the large language models, which is multi-agent functionality. And what this is we have, technically they're just functions, right? So each agent is its own function. And each one of those functions has its own system prompt, which I'll talk about in just a minute, has its own system prompt. And it has its own function calling ability. It has its own prompt. It may speak to its own model. And so what this ends up doing is, this is where the autonomous process comes in. These agents are each specialized with their own specialized model, and they can communicate with each other. They can check each other. We can have a system to where, like in the tabletop exercises, we have a note taker, we have an SME, we have a facilitator, and they all play their part, and they all talk to each other to double check each other. And so that's where the autonomous section comes in. But the most important part, and I'll get into an example here in a minute, but the most important part is the function calling. That's the real key. The ability to have a large language model can take the sentiment, the meaning of your question, and then call the right function in your code. That's the key. Multi-agent functionality with local open source models and the ability to call specific functions. And this is just a quick illustration of kind of how the agents work, but you would typically have a router agent or a coordinator, and it takes your prompt, and it should listen, or it should take the sentiment of what your prompt is, and then direct it to the appropriate agent with the appropriate model, the appropriate subject matter expertise. The foundation for all of these models using multi-agent system, retrieval augmented generation, mostly sit on a program called LangChain. We're not going to get into that because most tools now use LangChain as their base, but I encourage you, if you're doing app development and you're getting into this generative AI stuff, I encourage you to go check out LangChain, read their documentation, and it's really cool. You can do a lot of stuff with it. But all the tools I mentioned before, they use LangChain. In order to quickly build agents for prototyping, we use AutoGen Studio. You can use AutoGen raw on the code and just build your agents. You can also, ChatGPT or OpenAI has an assistance API, but again, it remains resident in OpenAI, and your data is going out there, so you want to be able to create local agents. And so we do that with AutoGen and AutoGen Studio to prototype our agents. This is a quick example of what the function calling, and so OpenAI, their models, their GPT models, they have function calling capabilities, but we wanted our own local models. We wanted the ability to communicate and call functions dynamically with any model. So it's a really simple way to create your function calling is you feed it a list of functions in a text document, and this is the prompt that we use that we found out works. You feed it the list of functions, and you feed it this prompt to where it spits back only the function name to call, okay? And I'm gonna jump ahead. This is what the functions text looks like. We have a bunch of these. You give it the function name, and you just tell it what that function is for. And so, again, the router agent reads the sentiment of your quote, or of your prompt, and it knows what function to call. When it does that, it's going to go here. You can see there in text. If it receives the name of the function in text, it routes it by calling that function, and then you feed the function your your parameters, your arguments, and whatever you want to feed in there. And this is key because now this gives you the ability to have an LLM figure out what function it's supposed to be using, dynamically call it based on the sentiment of your prompt, and feed parameters and data into that function. And so it's a very long discussion on how you do that specifically for all the different use cases, but that's the foundation of how you achieve the complex functionality in all of these use cases. And then finally is the prompting. This is where most people start. Creative prompting, prompt engineering, this is where most people start. But if you're going to build complex functionality, you're going to build apps on this, then it's not just taking a prompt and putting it in ChatGPT. It's learning how to use the open source models and fine-tune them and use augmentation and multi-agents and function calling, but prompts are important because it's the base, it's the foundation of everything. And so some quick tips is you always want to use a system prompt. What that is if you look at the API call, there's 3 different roles. You have a system role, a user role, and an assistant role. The system prompt is kind of like this thing that stays in there. It's ever present, and it gives the base and overall instructions. Now, these large language models are so broad that it can get lost. It can lose its way trying to find that analysis. Using a system prompt is basically, I don't know, it's like a map pin, and it gives the model a starting point. Okay, so it has been argued whether or not that you can actually, if there's any benefit to system prompts. I believe there is. I've seen evidence that there's benefit to it. And so you want to use formats and lists, and I apologize I didn't give an example here, but again, I'll provide that to you. So rules, lists, you want to tell it, this is what you should do, this is what you shouldn't do, always do this, never do this, and give it templates. If you want something printed out in a specific way, in a specific template, or specific format, tell it, hey, I want the results printed out like this, and it will follow that. There's a technique called chain of reasoning, which is the way that AI or the large language models typically works is it just beelines to the objective in a straight linear line. It doesn't have the ability to come back and reevaluate its answers and then pick the best one. But you can tell it to do that. You can say things like, give me 3 possibilities, choose the best one. You can also do things like say, do this step by step, think step by step. And this gets even easier when you have multi-agent functionality in there, because then you can say, hey, I want you to generate 3, 5, 10 ideas. Then you go to this one and say, hey, I want you to look at those ideas and tell me which one's the best. And then you have your QA agent come and say, all right, I looked at your end result there, and I don't think you wrote this right, and I think that you need to improve upon this. And it's like a project manager and a developer. And so that's kind of the chain of reasoning is simply, make it think step by step. Give it the ability to back up and reevaluate its answers. And you want to be as specific as possible. If you're too generic, you've probably seen this before in ChatGPT. If you're too generic, it'll hallucinate, it'll go all over the place. But if you're very specific and detailed, then I've gotten better results. However, it can get to a point to where if you're trying to cram too much detail into it, then it actually gets confused. It can't do too much at once. So you want to be detailed, but don't feed it a book of detail. So when you're thinking about developing AI into your application or your process or whatever, these are the general tips. Number 1, you want to understand the limitations, privacy, security. So understand that if you're not using a private open source model, that you could be putting sensitive data out there. You want to understand that it's not always right. So just educate yourself on the limitations of whatever model you're using or whatever system you're using. The second one, I've said this before and earlier in the presentation, this is probably the most important. You're not using AI to do things for you. You should not be using AI, or again, generative AI. You should not be using generative AI to completely do a task for you, whether it's writing or writing code or whatever. It's there to do the mundane tasks better and more efficiently. Those things that take you longer, it's there to help you. always keep the human in the loop. It always needs to be evaluated. Now, I don't know, 5 years from now, we may all be replaced. Who knows? I kind of hope that happens because I'm lazy. But at the end of the day, it's there to augment you, not replace you. Don't think that it's going to do all your work for you. And prompt drift, I'm not going to really talk about prompt drift because prompt drift is one of those things to where if you're using a public model where they're constantly changing, you need to work on that. But we're talking about open source, so you don't need to worry about that. It's just basically where they change the model so the prompt you use last doesn't quite work like it used to. So in summary, here's how we're achieving all the things that we're doing. And I apologize, it's only 25 minutes, you can only go so deep and technical. However, I got a surprise for you here in a minute. So we're using all open source LLMs to keep everything private, and we're using fine-tuning and retrieval augmented generation to hone in on the task. We use LM Studio and Ollama for quick prototyping of agents and POC. And we typically use Ollama for our back-end scripts as our API. And then we use our custom agents and custom function calling. At some point, yeah, there may be function calling support in open source models, but we got around that. But function calling and agents, that's the key to everything. And then we use AutoGen Studio to prototype our agents. So here's where we have, this literally just got started. So there's still information being uploaded, but this is free, it's open source, it's on GitHub, and we're creating an entire community where we're building LLMs fine-tuned specifically for OT cybersecurity. We have tools, scripts, instructions, videos, resources, so it's not complete yet. Just give us a couple weeks and more will be there, but there's stuff there now. And it's there for the community to use. All the things I talk about, all the things that I teach and how to do this, it's there. So we definitely want people to help, contribute, and participate. So I know that, hardly have any time for a question and answer. We got some. So if I don't get to all your questions here, I'll be hanging out at the Industrial Defender booth on the 3rd floor. Come see me for more questions. But that's it for now. If we have questions.
Yep. We still have time for 1 or 2 questions. So, anyone? Okay. Sir? Here. Excuse me. Yes. Here.
We do have a question or we don't?
Yeah, we're getting one question.
Okay.
Yeah.
Y'all shouldn't leave. This is going to be a very important question.
Yeah.
No pressure. Well, this will be disappointing probably, but I just recently read about Musk's suit against the OpenAI people and probably missed half of that argument. But I noticed a couple times today you used together in a number of sentences, both private and open at the same time.
Yeah.
Can you unpack that a little bit? They seem contradictory, and yet they obviously aren't.
I can't comment on the structure of OpenAI as a business and what's open and what isn't. I can tell you, and I don't know if this is answering your question, I do know that if you look at the document of the lawsuit, which I have, it's basically OpenAI's concept or their premise was to be open source for the good of humanity, and then Sam Altman partnered up with Microsoft specifically because he saw the profit, or supposedly they saw the profit in that. And if you look at the business structure of OpenAI, they have there's 4, 5, 6 different sub-entities and all of that. And so, I can't speak to how it's structured, and I can't really speak to what's open source and what's not and what's going to be. Right now, all the GPTs are closed source, but if I had to guess, I would think that Musk will probably win partially in his lawsuit, and some of the OpenAI GPT models will be open sourced, and I think we'll learn more about G-Star, or Q-Star. What is it? Q-Star, right? Yeah, Q-Star.
Yep.
Is that what you're asking, or?
Yes. I think you went beyond what I was asking.
Sorry, I do that.
But no, that was great, but missed one. Open and private seem to mean different things.
Yeah. So you're right. That's a good question. So yeah, open source simply means that the model is available to the public to use commercially or non-commercially, depending on the terms, and all the weights are published. And private just means that I'm using it locally without sending my data, my inferences, out to the cloud. And that's what private would mean.
Perfect. Thank you.
Thank you so much for that, Guy. Now, thank you again, Clint, for that insightful presentation.
Thank you.
Yeah, since we won't have time for additional questions, you can grab Clint Industrial.